Welcome to Chapter 6, Lesson 6. We will be graphing systems of inequalities. What this means that we'll be graphing more than one inequality, and our solutions are those that have double layers of shading. So when we look at this picture over here, you can see that there is an inequality that's shaded with red. There's an inequality that's shaded with blue, and then there's an area right in here that has double shading, and a solution to this inequality would be anything on this solid line, above this dotted line, and anything in here, but it could also extend even further off to the right. The standard that we're going to be looking at is graphing linear inequalities and systems of inequalities. So a couple things that I want to make sure that we remember when we're graphing inequalities. Y is greater than x plus 1. So this means that we have a y-intercept at 1. This also means that we have a dotted line because it doesn't say or equal to. And it also shows that we have a slope of positive 1. Now, if you were to take the x out of the picture here, this would be left with y is greater than 1. So think about what numbers would be greater than 1. What y-intercepts would be greater than 1? You could have 2. You could have 3. Okay, you could have anything above that, and because those x's are above it, then that means that that's what we're going to shade. We're going to shade where those x's are at. So we have a dotted line. We've shaded above the line. Now, what if we shaded y is greater than or equal to x plus 1? Now, this one has a y-intercept also of 1. But it has a slope of 1, so up 1 over 1, up 1 over 1. So this one's going to have a solid line. And think about this. If you had a y-intercept of something bigger than or equal to 1, you would have a y-intercept of 2 or maybe even 3. Therefore, you're again shading above the line. Down here where we have y is less than x plus 1, we again have a y-intercept of 1. We have a slope of 1. So we have a dotted line increasing from left to right. But this time it says less than. So if you were to think about, take the x out, what numbers would be less than 1? Y-intercepts that are less than 1 would be 0, negative 1. Those are both below my inequality line. So I am shading below the line. And then y is less than x plus 1, again has a y-intercept of 1, a slope of 1, but this time we have a solid line extending in both directions. And if you were to think about numbers again that are less than a y-intercept of 1, you would have 0, negative 1, and so on. So again, we would be shading below the line. Now, with inequalities, systems of inequalities, this means that we have more than one inequality. So we're going to graph the first inequality in blue. My first one here is y is greater than negative x minus 2. So this first tells me that I have a y-intercept of negative 2. This also tells me that I have a negative slope, so this means I'm going to go down 1 to the right 1, down 1 to the right 1, down 1 to the right 1, and continue on. I could also go up 1 to the left 1, up 1 to the left 1. Now, because this doesn't say or equal to, that is my cue that it's going to stay as a dotted line. So we're just going to extend that dotted line throughout the entire graph. Now, if I thought about y is greater than negative 2, numbers that would be bigger than negative 2 would be negative 1, 0, 1, and so on. So now I'm going to go ahead and I'm going to shade above my line. So everything that I'm shading is including those y-intercepts that are above the line. So we show everything above the line. And remember, because this is an inequality, that can extend that way, can extend here, and here, and here. What that means is that any solution that's covered in that blue or extending where those arrows go could potentially be a solution so far. But now we need to also graph our second inequality. Our second inequality has a y-intercept of 6, so that's my starting point. So from my origin, I'm going to go up 1, 2, 3, 4, 5, 6. So my starting point is right here at 6. My slope is 3x, so I need to go up 3, I can't go up 3 over 1, so I need to go down 3 to the right 1. So my next point is going to be right here and then I go down 3 to the left 1 again, down 3 to the left 1, down 3 to the left 1. Now notice that on my second equation, the inequality has that or equal to sign. So this is my clue that I am not going to have a dotted line, but I'm going to have a solid arrow extending in both directions from that point on. Now, if I were to think about my inequality over here, without the 3x, I would be thinking what numbers are less than a y-intercept of 6, which includes 5 and 4 and 3 and so on. So that tells me that I'm going to be shading everything below that line. Now, when we're looking for a solution to a system of inequalities, we're looking for the area that is double shaded. All right? Anything that is on the dotted line cannot be included as a solution, but anything on the solid line could be. So if I look at this point right here, I could include that point as a solution because it's on the solid line. So a possible solution would be -1, 3. Now if I put a point right here on that dotted line, that would not be included because it's a dotted line. So it's not a possible solution. I could also pick anything in this area as a solution or extending, which if I extended my graph would also be double shaded. So another possible solution would be right here where I have the point 5, 3. Now there are infinite solutions because those arrows extend forever and ever and ever beyond those lines. But the clue here is anything that is double shaded or on a solid line works as a solution. Now this one's same type of situation. Don't be fooled just because we have an x is greater than or equal to 4. What this means is that you have a y-intercept of 4. So if my y-intercept is 4 and it says greater than or equal to, then I know that I have a solid line because it says greater than or equal to right on the x-axis of 4. Now what numbers would have been bigger than 4? Well, 5 would have been bigger, 6, 7, and so on. So when I go to shade, I need to shade everything to the right of the line. So far, anything on the line is a solution, and anything to the right of it. Now the second equation we're going to graph is the one that we're going to graph in blue. My y-intercept is 3. My slope is -2. So down 2 to the right 1, 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 down 2 to the right 1. It does not say or equal to, so this is going to be a dotted line extending in both directions. And if I think about taking the -2x out, what numbers are bigger than a y-intercept of 3? We would have 4, 5, 6, 7. So therefore, that means that I'm going to shade above the line. So now possible solutions would be anything on the dotted line, on the solid line here, and then just above the dotted line, not including the dotted line. So a possible solution could be 4, 0. Another possible solution could be 4, -4. You could not have a solution right here at that point of 4, -5. The reason for that is because part of that point is on a dotted line and part of it is on a solid line, but because it's on a dotted line, that one wouldn't work. But anything that's double covered, if I had this point right here, which is 7, -1, that also would work as a possible solution. Alright, so we have y is greater than -2. This is going to be a dotted line going through the y-axis at -2. Intercepts that would be bigger would be above that line, so I'm going to start off by shading everything above the line. My second equation, we will switch over to red. It has a y-intercept of 4, so the first point that we're going to make is a point at 4. My slope is -2, so down 2, right 1, down 2, right 1, and so on. I can go up 2, left 1, up 2, left 1. This is going to have a solid line because it says or equal to, and then numbers that are less than a y-intercept of 4 would be here, 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 and so on. So when I go to shade, I want to switch that to red. I want to switch that to red. Here we go. There we go, red. And we're going to shade below. So a possible solution is anything on the solid line, anything above the dotted line, or anything double shaded. So a potential possible solution could be -5, 0. Another one could be -4, 3. Could the point 0, 4 work? Think about that. Yes, it could. Could the point 0, -2 work? No, it can't because it's on a dotted line. So if it's on a solid line, it works. If it's on a dotted line, it won't work. Alright, I'm going to pause here. I'm about to my ending of the time. I have a couple more examples that include 3 inequalities, so make sure that you come back and you watch part 2 of this video, because when you have 3 inequalities, that's completely different than what we've already been graphing, and it's really important to make sure you understand how to do those as well. Thank you. We'll see you in part 2.